Alright, welcome to the first lecture of this course on what is Python. Well, Python is a high-level, general-purpose and a very popular programming language. Just like humans, computers also use multiple programming languages to communicate in this case. However, a programming language is simply a particular way to talk to a computer using instructions that both humans and the computer can understand. There are programming languages named after people, such as Ada, Pascal. Some were named after simple acronyms like BASIC and Fortran, and even a few named after TV shows like Python. Yes, you could be wondering, but the Python programming language was not named after the giant snake we all know as Python, but the language was named after the Monty Python's Flying Circus, which is a BBC comedy TV series from the year 1969. Python programming language was created by Guido van Rossum in 1991, and the language has grown in popularity among people of all ages and industries, thereby making it the language of choice today. A number of things about Python programming language makes it extremely useful for beginners. Most importantly, you can use Python to write simple, efficient programs really quickly. It is an easy-to-learn programming language that has some really useful features for a beginning programmer, because the code is quite easy to read as compared to other programming languages like C++ or Java, and doesn't have a lot of complicated symbols like braces, hashes, and dollar signs, which make other programming languages a lot more difficult to read and therefore a lot less friendly for beginners. There are several reasons why Python is the best programming language in the tech industry. Starting from AI and machine learning to web development, data science and analytics, building web, mobile and desktop apps, game development, and even cybersecurity. Python is a cross-platform programming language, which means a Python program written on a Macintosh computer can run on a Windows machine, as long as the Windows machine has the Python interpreter installed. And also, the same program will also run on a Linux system. Lastly, Python language has speedy deployment. So in this section, we will learn how to download and install Python on our computer. Well, installing Python is fairly straightforward. And here we will go over the steps for installing it on a Windows and Mac operating system. After installing Python, you will also set up your IDE program, which is the integrated development environment that lets you write programs for Python. But if you have Python already installed on your computer, then you can skip this video and jump ahead to the next lecture. So on python.org website, which is the official website for Python, you can go to the download section here, and this button lets you download Python 3.10.5. This is the latest version of Python as of now when recording this tutorial. And however, in the future, yours might be quite different because the maintenance of Python keeps updating to the latest version of Python that allows you to use all the new features. So go ahead and click on the download button to save the software to your file system. And when it's done downloading, open up the file package and follow the instruction to install the software on your computer. And however, if you are on a Windows computer, you can click on the download section here, and instead of Mac, you'll see download Python for Windows operating system. Then click on the download button to also save it to your computer. And when it's done downloading, open up the file and install the package on your Windows machine. And finally, let's actually verify to see if Python has been installed successfully and is actually working fine on our machine. So if you are on a Windows computer, press the Window key plus R, then type in CMD, which is short for command prompts, and then press the Enter key or the OK button here to open up your terminal window. So here on the terminal window, what I need to do is to type in Python and then press enter. And as you can observe here, Python has been installed and is working perfectly on our Windows machine. So to also verify the installation on a Mac computer, press the command key plus spacebar to open up your Spotlight search, and then type in terminal and press enter to launch the terminal window. And here is my terminal window on a Mac computer. So I'm gonna type in Python 3. This is because the Mac computer comes with Python 2 as default, which is the older version of Python. So instead of using just Python as we did earlier on Windows, we type in Python 3 and then press enter. As you can see on the terminal, we have Python installed successfully on our Mac computer. And however, this is called the Python shell, which is part of the Python integrated development environment. And the three greater than signs here are called the prompts. So let's actually type in an expression like 2 plus 2 and then press enter on your keyboard. So you should see a 4 appear on your window. And also, the prompt should reappear to let you know that Python shell is ready to accept more commands. So in essence, you have given the computer an instruction to execute 2 plus 2, which is an instruction that both you and the computer can understand. So in the next lecture, we are going to see how we can set up our development environment for writing and executing Python code, because we are not going to be building real-world projects and writing so many lines of code on the terminal as we did above. However, we need a code editor to build real-world applications. So I'll see you in the next lecture. Take care. Hi, and welcome to this lecture on where we're going to be setting up our own development environment on our PC. So, as I mentioned earlier on the previous lecture, we can't actually code large software projects on the terminal. So, we actually need a code editor. And a code editor is a tool that is used to write and edit code. They are usually lightweight and can be great for learning. However, once a program gets larger, then you actually need to test and debug your code. And this is where the IDEs come in. An IDE is the short acronym for Integrated Development Environment because it understands your code much better than a code editor. However, it usually provides features such as build automation, code linting, testing, and debugging. So, using the IDE can significantly speed up your work and development. But the downside is that IDEs can be complicated to use. So, some of the few examples of code editors are VS Code, Notepad, and Sublime Text. On the IDEs, the most popular IDE for running Python is the PyCharm and Jupyter, which is mostly used by data scientists and machine learning practitioners. But for this course, we're going to be using the VS Code editor to run our Python code, because I'm going to show you how you can convert VS Code editor to a powerful IDE which provides wonderful features such as intelligent code completion, linting for potential errors, debugging, unit testing, and so on. So what I need you to do is to head over to code.visualstudio.com, then download Visual Studio Code Editor, and when it's done downloading, install on your operating system if you are on a Mac, Windows, or Linux. After the installation, open up your VS Code editor and open the Explorer tab here and click on the Open folder. So on my desktop, I'm going to create a new folder. Let's say Python Programs, and then click on Create. Then finally, I'm going to click on the Open button here to open up the Python Programs folder to my VS Code. And as you can see, we are on the Programs folder. Then I'm going to create a new Python file called app.py and then click on Enter. If you notice, VS Code added a small Python icon indicating that this is actually a Python program file. So now, all you need to do is to click on this icon. It's actually called the extension panel. Then we're going to search Python and then click to view the extension. So as I mentioned earlier, that I'm going to show you how you can convert VS Code editor into a powerful integrated development environment. So this Python extension provides us with features such as code linting for checking our source code for programmatic and stylistic errors, then debugging for identifying problems in our source code and determining a way to work around it. And we have code navigation and many more. So click on the install button here to download the extension to your VS Code, and when it's done installing, close the extension page. And now let's actually write and run our first Python program, starting by using the print function. Well, functions are code that tells Python to do something. You can use functions in your programs again and again as many times as you want, because they are the one way to reuse code in programming. However, we always add double parentheses when we call functions in Python. And then in between the parentheses, we include double quotes. You may also use single quotations in between the parentheses. And finally, all we need to do is to pass in the message we're going to display on the screen, which I'm going to say, "Hello world." Then at the top right section here, I'm going to click on the run button to display my message. This is awesome, right? As you can see, the message "Hello World" has been printed out on the console. And this is all we need to do to display a message on the screen in Python using the print function. However, this is not all we can do with the print function. We can also print out numbers, expressions, and so on. To illustrate, I will erase the "Hello World" message with the quotations and pass in 4 multiplied by 3 and then click on the run button. As you can observe, 12 has been printed out on the console for us. So to recap, the print function displays output to the screen, which can be text, numbers, or even expressions. And later in the course, we will explore advanced features on how to use the print function to display information on the screen. So this wraps up our tutorial. And in the next lecture, we're going to learn about variables, which are the way of storing data in Python programs. For example, if you create a computer game, you actually need to track the player score, the number of lives the player has, and what level the player is on. Of course, all of this data changes as we play the game and as the software keeps running. So, as the programmer, where do you actually store all of this data and how do you keep track of it? Eventually, the Python programming language has a wonderful solution. You will store all of this data in variables. So, I'll see you in the next lecture. Stay tuned, and as always, take care. Welcome to another lecture on Python variables. Well, when you think about programming and software at high level, it's all about manipulating data. As I mentioned earlier on the previous lecture, that we use variables to track player score, number of lives that the player has, and the level of the player. Therefore, what is now a variable? In short, a variable is just a container for data. The most important thing to understand about Python variables is that they both have a name and a value. For example, if I want to track my age inside a program, I can simply create a variable called my age, which my age is the name of the variable. But because my age is just a container for data, and I can also give it a value, So I can put the number 32 inside my age. In programming language, this is called assigning a value to a variable. So as time passes and our program runs, we might need to update this variable, and we can do that simply by updating the value inside my age with a new value. So we can replace the value 32 with the value 33. So the question is, what will this look like in Python syntax? So back to my code editor, I'm gonna create a variable my age and use the equal sign to assign the value 32. So this name my age is now how we can refer to the number 32 in Python programming. And to display the value inside my age variable, I'm simply gonna use the print, open brackets, my age. Then I'm gonna click on the run button to display the value on the console. So suppose our program is now running and we need to update my age variable. We can do that by simply assigning a new value to it. Let's say my age equals 33. If I write print and then my age and click on the run button, then we will see the value 33 printed out on the console. Nevertheless, there are so much that you can achieve on how to update my age variable. For example, if we say my age is equal to my age plus 1. Now, if it's your first time learning to program, this line of code is actually going to look very strange. But what's going on here is that we are taking the previous value of my age, namely the value 33, on the right hand side of the equal sign, and then adding plus 1 to it. With that equal sign operator, we are storing this new value of my age 34, which is 33 plus 1 inside of my age at the left hand side. In other words, we are overwriting the previous value stored inside of my age variable. If we print my age now and click on the run button, we will see the value updated to 34. Now, let's do a quick exercise on using and manipulating variables in Python. So, as a challenge, can you create a program to calculate the area of a rectangle? What I need you to do is to create a variable called rectangle length and set its value to 10. And also create another variable rectangle breadth and also set its value to 5. And finally, create another variable called rectangle area and assign its value to rectangle length multiplied by the value rectangle breadth. Finally, print the value of rectangle area on the console. And you might be wondering about these 4 lines with the hash symbol. Well, these are actually Python comments. The Python interpreter ignores and also doesn't execute any line of code in Python starting with the hash symbol because the Python interpreter treats that as a comment. As a programmer, commenting your code helps you and others to understand the intention of your code later in the future. This allows you to more easily find errors, fix them, and improve the code later on. So it is an essential part of your workflow and is seen as a good practice for good programmers. In that case, I will give you a few seconds to pause the video and give this challenge a go. Alright, so here is the solution. I'm gonna create a variable rectangle length equals to 10. And then for the second part, I'm gonna create another variable rectangle breadth with the value 5 assigned to it. And for the last variable, which is area, I'm gonna assign the expression of rectangle length multiplied by rectangle breadth. Then finally, I'm gonna print out the value of rectangle area. So when you click on the run button, you will see the value of rectangle area, which is 50, printed out on the console. Perhaps one thing that could have happened to you at this point is that you made a typo. In programming, everything is case sensitive, and if your variable names didn't match exactly to how they were defined, then you're gonna get some unexpected errors. For example, if this capital A in our print statement instead was a lowercase a and run the code, then we would get the following error, which as you can see, it's actually a name error. Name rectangle area is not defined. And this is because this rectangle area and this rectangle area are considered to be completely different entities. So you want to make sure that you never have any typos in your variable names. And the same thing happens if we miss a letter. For example, if we wrote rectangle length instead of rectangle length, when we run the code, then we would get exactly the same error. Our variable is not defined. In other words, the Python interpreter can't find something that matches this name. So let's wrap up our tutorial with something interesting about the variable names we've just written. Well, if you observe my variable names, I use the uppercase letter for each word. However, this is called coding style. But what do I actually mean by coding style? Well, coding style is whether you use capital or lowercase letters, whether you use tabs or spaces, where you put your curly brackets, and so on. It's actually how you arrange your code or what sort of syntax you use. Now, the thing about programming style is that the standards varies from various programming languages. So, the mainstream Python programming language is a little different from the mainstream Java program, which again is different from C++. So, the question is, how do we find what good Python programming style is or should be? And what are the guidelines we should follow? Or what are the guidelines people tend to follow? Well, lucky for us, there are so many style guides out there on the internet. And the most popular style guide these days is the official one from the Python Software Foundation, and it's called PEP 8. It's pretty long and comprehensive, and also not something that you should tend to follow religiously, because it's actually a suggestion for writing readable Python code that is readable for humans, because the computers don't really care. So if you click on the naming conventions on the left hand side here, under descriptive naming styles, you will find different naming styles in Python. For example, you can use single lowercase letters to name your variables, or single uppercase letters, or even lowercase letters, and so on. And this is based on the Python Software Foundation, because this is not the only style guide out there. In fact, many companies have their own style guides too, and might be slightly different from the style guide from the Python Software Foundation. So, here is the Python style guide for engineers at Google. Now, looking through this and trying to spot the difference between the Google style guides and the Python Software Foundation. The thing is, these two style guides are very similar, but there are some differences because the Python Software Foundation says code line length should be 79 characters, and Google says the maximum line length should be 80 characters. So, as I said earlier, most of the suggestions are really very similar. And one of the things I found really interesting to me is that Google says to be consistent. And this is the formatting they use, all caps. And in contrast, the PEP 8 style guide from the Python Software Foundation says a foolish consistency is the hobgoblin of little minds. So what they're really saying here is that you can be a bit more flexible in your coding style if you need to be. So in the end, style guides are just readability of code. You yourself can make a choice. You can choose from one of these style guides and just stick to it if you actually need to. So therefore, we've come to the end of this tutorial and I'll see you in the next lecture. Take care. So now that we've learned a little bit about Python variables, let's talk about a key concept that you need to understand when working with variables, namely data types. In Python and programming in general, we will be working with different kinds of data. We will be working with text, decimal numbers, tables of data, images, sounds, videos, and all sort of data. And programming languages like Python will categorize this data. In other words, different kinds of data like text or decimal numbers and whole numbers will have a different category, meaning they will have a different data type. So for example, if you try to put a decimal number where Python expects to have a string, you'll often find that you have a problem. And let's say you want to divide two things together, and those two things are actually numbers, 10 divided by 5, then you are actually good to go. But if one of those things is actually another kind of data, like a home address, which is actually a string, then you're going to have a problem and the program will crash with a type error for trying to evaluate an integer with a string, which doesn't really make any sense. For the most part, Python takes care of data types behind the scenes. And let me show you how you can actually see the data types in Python. Because we can ask Python what category something belongs to by writing print, then type, parentheses, and then putting something in between those parentheses. So for example, if I write type 50 and run the code, then you're gonna see that the type of this whole number is int. And int stands for integer, which makes sense, right? But let me introduce you to quite a few other types. If we also say type 50.5 and then run the code, then we get to see that decimal numbers are classified differently. Decimal numbers are classified as floats or floating point numbers. And floating point numbers are the type you will usually be working with every time you are dealing with numbers that have a decimal point. Now, let me show you the type a text is called. So I can write type and then in between the parentheses, I'm gonna open the single quote and add my name. When I run the code, then I can see that the type of text is called str, and str stands for string. However, you can think of the word string as just a piece of text or sequence of characters. And the way that you can tell that something is considered to be a string is by the fact that strings are always surrounded by either single or double quotes. And as you can observe, the VS Code editor is actually very helpful with the syntax highlighting, so that the Python code that is considered to be a string actually has a different color. So in this case, strings are marked as green. So now the question arises, how do data types relate to variables? And what's the connection between the two? Well, if the data type have some certain type, so does the variable containing the data, because after all, a variable is just a container. So for example, when I create a variable called my age and assign its value to 20, so let's actually see the type of the variable my age. I'm gonna type print parentheses then the type of variable, and in between the parentheses, I'm gonna supply my age variable and then run the code. As you can see, because my age holds onto a whole number, then the data type of the variable is int, which, as I mentioned earlier, it's called integer. So changing the value of my age variable to, let's say, 20.5, and then running the code once again. So as you can see, since my age variable holds to a decimal number, which is 2.5, then the type of my age variable is now a float. Finally, when I rename my age variable to my name and then set its value to the string Shuaib, then also instead of my age here, I'm then gonna pass my name variable. And when I actually run the code, then I can see that my name variable is actually a string. So let me ask you this. How do you think we're gonna print this statement exactly using Python? One thing to keep in mind is that this statement has single and double quotes in it. And this is the mystery we're gonna be exploring over the next lecture. But I want to throw this to you as a challenge. Can you try to figure out how to print this statement on the screen using Python? So I need you to give it a go. And in the next lecture, we're going to look at the solution. I'll see you there. Take care. In the previous lesson, we talked about some of the Python data types like integers, floats, and strings, and also how to find the category of a particular data type in Python. So in this lecture, we're going to get our hands dirty with more concepts when using strings in Python. But before then, let me actually give you the solution to the problem I gave in my previous lesson. So to recap, we usually call text strings in Python, and you can think of a string as a collection of letters. In Python, we usually create a string by putting quotes around the text. However, if you start your string with one type of quote, let's say a single quote, and then try to finish with another type like a double quote. So when I print my message and run the program, then you will get an error message, which is a syntax error, unterminated string literal. And this is because you did not follow the rules of ending a string with a single quote. So to avoid this error, we have to end our string with a single quote instead of double quotes. However, if you look at our text, we have words like aren't, can't, shouldn't, and wouldn't. And for each of these words, we need to add single quotes before the letter T. But when I add a single quote here, also in can't, shouldn't, and also wouldn't, then we get to see that Python doesn't expect or recognize all of this bunch of other characters after this single quotation mark. So when Python sees a quotation mark, either a single or a double quote, then it looks for the next matching quote and also expects you to end with that same quotation mark on that line. So in this case, the starting of our string is the single quotation mark and also ends here. And also another string starts here with a single quotation and ends here also. And lastly, the string here. So remember that Python itself is not as smart as a human being to recognize all of these characters in between. And when we try to run this program, then we get a syntax error. So to resolve this problem, I'm simply gonna add a backslash before each quotation mark within the string. In Python, this is called escaping, and it's a way of saying to Python, yes, I know I have quotes inside my string, but I want you to ignore them until you see the end of my quote. So when I run my program, then we get to see that our message has been printed out on the console without any error message. But one thing to keep in mind is that escaping strings in Python can make them harder to read. Still yet, you might come across snippets of code that use escaping. So it's good to know why the backslashes are there. But let me introduce you to a very handy feature in Python for handling strings. This is called multi-line strings. So let me show you how it actually works. I'm simply gonna pass in 3 single quotations here instead of one single or double quote. And also, at the end of my string, I'm also gonna add 3 single quotations again. And finally, I'm gonna remove these backslashes in my string. So however, when I run my program, we also get to see that our message has been printed out on the console without any error message. And this is because the 3 single quotes allows us to combine double and single quotes in our string. In fact, if we use 3 single quotes, we can put any combination of single and double quotes in our string, which is pretty awesome, right? So now let me introduce you to quite a few other methods in string manipulation. For example, if I say print, then open my parentheses and then pass in this piece of string. Then use the plus sign operator to append it to the string of letter n. And when I run the code, then you will see that Python added these 2 pieces of strings together for us and printed them out on the console. And I can still use another plus operator to add another piece of string. So let's say programming. And when I run the code, then we get to see that Python programming has been printed out for us. So in Python, you can actually add 2 or more pieces of strings together and print them out on the console. And however, not just adding strings together, we can also multiply strings in Python programming. So to illustrate, I'm simply going to pass in the string Python to my print function and then multiply by 3. And when we execute this program, then we will see that Python has been printed out 3 times for us. So in summary, we can multiply strings by integers and display them out on the console in Python programming. So now, let's talk about a key concept that you need to understand when working with strings in Python, which is embedding values in strings. For example, if I create a variable called my age and set its value to 20, and also create another variable called my message and set its value to the string I am %s years old. However, let's say you want to display a message using the content of this my age variable, which is gonna be I am 20 years old. Then you can embed the value in the string using the %s, which is like a placeholder for a value that you want to add later in your string. So in this case, this placeholder is for the value my age variable. Then finally, we will call the print function and then pass in my message. Then we use the % symbol to tell Python to replace the %s with the value stored in my age variable, which is 20. So when I run the code, then our message will be printed out on the console, which is pretty awesome, right? Another interesting thing to note is that you can actually use more than one placeholder in your string. So to illustrate, I'm simply gonna create another variable called my name and set its value to the string my name is Shuaib. So in my message, I can create a placeholder here at the beginning of the string. And here on our print statement, one of the things to keep in mind is that we are using two placeholders in my message string, which means two variables, my name and my age. So I'm gonna pass in my name and comma. And finally, we're gonna wrap our two variables in parentheses. However, another thing to note here is the order. My name has to come first for this placeholder, then my age for the second placeholder here. And when I run this program, then we get to see that my name is Shuaib. I am 20 years old printed out on the console for us. So to wrap things up, we've come to the end of this tutorial. And in the next lecture, we're going to be exploring more methods regarding Python strings. So have a nice day, and I'll see you in the next lecture. Take care. Hello and welcome to this lecture on string methods and formatted strings in Python. So in the previous lecture, we've learned about how to format a string by embedding values using placeholders. So let me introduce you to a new way to do string formatting in Python. It is called fstring. This new way of formatting strings is very concise and convenient because it lets you use embedded Python values and even expressions inside the string. So, for example, I can change the value of my age variable to 20 plus 5, and on my message variable here, I'm gonna add a letter F before our string. And this tells Python that this is actually an F string or formatted string. And as we all know, here is the placeholder of my age variable. And instead of the %s here, I'm simply gonna add curly brackets and pass in my age variable. And also do the same with this %s. I'm gonna erase and add my curly brackets. Then at this moment, I'm simply gonna add my name variable. And finally, on my print statement, I'm gonna erase all of this and leave only my message variable here. So when I execute this program, then my name is Shuaib, I am 25 years old has been printed out on the console for us, which is pretty awesome, right? So another wonderful thing to note here is that I can even make my code to be more concise and short by removing my age variable. And then at the placeholder here, I can pass in an expression like 5 multiplied by 5. And when I run the code once again, we then get exactly the same statement. My name is Shuaib and I am 25 years old. So, however, formatted string is a great way to format strings in Python, not only making your code more readable, but more faster and concise, and also less prone to error than the other ways of formatting strings in Python. And as I mentioned earlier, don't forget to add the letter F before your string, because this tells Python that it's actually a formatted string, and Python should look at the values inside our curly brackets and substitute them with values of their respective variables. So now, let's talk about string methods in Python. These are useful built-in functions that allows us to manipulate strings in Python programming. For example, when I create a new variable called txt and set its value to the string welcome to softlinks, and when I say print and then in between the parentheses, I can call the len function. So in Python, we use the len function to count the number of characters in a string. So once again, in between the parentheses of the len function, I can pass in my txt variable. And when I run my program, then we get to see that the number of characters, which is 20, has been printed out on the console for us. But one thing to note here is that the len function is not only limited to strings. So later in the course, we're going to be exploring how to use the len function to other data types in Python. So however, in Python programming, we have quite a few other functions that are just specific to strings. So to illustrate, I can remove the len function, and then when I type txt, then dots, so we see all the functions in Python that are available and also specific to strings. And these are often referred to as methods in programming. So when I select the upper function and then run the program, then we see that our string has been printed out in uppercase letters. So another thing to note here is that this function returns a new string. So the original string in our txt variable is not affected. When I say print, then pass in my txt variable and run the code once again, then we see our original string at the bottom. And here is our new string we got using the upper function. Another useful function is the .lower method. So when I run the code, and this returns a lowercase string by converting each uppercase character in our string to lowercase. Also, another useful method is the .count method, and this function returns the number of times a particular value or character appears in a string. So to illustrate, in between the parentheses, I'm gonna pass in character O in a string format. And then when I run the code, then we get to see that the letter O appears 3 times in our string, welcome to softlinks. Again, another method is the .index, and this function searches the string for a specified value or character and returns the position of where it was found. So for example, I can pass in the letter I. And lastly, we also have the .replace method, and this function is often used to replace characters in strings with another kind of character or value. So for example, I can replace the letter O, comma, then with the letter I in our string. And when I run the code, then we get to see that .index function returns the position where our letter I is located in our string, which is 16. And also, we can see that the replace function also returns our string while replacing the letter O with the letter I. So as I mentioned earlier, this is actually a new string, and our original string in the txt variable is not affected. So this wraps up our tutorial on string methods in Python. So be sure to try out other methods regarding strings as well. And also check out the Python documentation for more information regarding those functions. And in the next lecture, I'm going to be introducing you to collection of data in Python, which comprises of lists, arrays, and so on. So have a nice day, and I'll see you in the next lecture. Take care. So in this lecture, we're going to be looking at Python lists. In other words, I'm going to be introducing you to collections. In the previous lessons, we learned about how to store data inside variables, and we also learned about data types in Python. So in Python and programming in general, we often need to work with a lot of data. So it would be silly if we put each piece of data inside a separate variable, just like this. Alternative to assigning a single value to a single variable like this is that we can have a single variable that contains a lot of data, and that variable will represent a collection. One of the most common type of collections that you would often encounter is the list. Lists are built in into Python and are part of the language. So let me show you what a list looks like in Python. Let's say I'm gonna create a list of prime numbers and set it equals to the collection of 5 primes. So the way to do that is by using the square bracket syntax. So I'm gonna open the square bracket and then give my first value, which is 2. Then put a comma. Then give my second value, which is 3. Then another comma. Then my third value, which is 5. Another comma. Then 7. And finally, the last value, which is 11. So, however, we've now created a variable called prime numbers, which holds to the collection of 5 values. Now, just out of curiosity, let's actually take a look at the type or category of the variable prime numbers. So I can call my print function and say type parentheses and then pass in prime numbers variable. So when I execute the program, then we see that the type of this variable is called list. So one thing to note is that the list in Python doesn't have to be numbers alone, because a list can contain all sorts of data. For example, here is what a list of strings looks like. So I can create a variable called names, which is equal to square brackets, then single quote, Shoaib, then comma, single quote, Khalid, another comma, then single quote, Adam. And one of the important things to note here is a list is just a variable that holds onto a bunch of values, and it can even hold onto values with different data type. So check this out. I can also create another variable, let's say prime and people, and set its value to equal to square bracket, single quote, Shuaib, comma, 11, comma, 3, comma, and single quote again, then Khalid. So now, even though that we have 3 different lists, one with whole numbers and one with bunch of text, and also the other with mix of numbers and text. However, all of these 3 variables are of the same type. They are of type list. So now that we've covered the syntax of creating a list, I'm going to show you something even cooler than storing data in a list. And this is adding 2 lists together. So in Python, we can actually join 2 pieces of list together, which may even contain different kind of data type. So to illustrate, I'm simply going to create a new variable, let's say noList, and set it equal to prime numbers plus names. So I can also say print, then pass in my noList variable here. And when I run the code, then we see both our prime numbers and list of names in a single piece of list. So the question is, how do you actually pull out a particular value from one of these lists? So here is the secret. The way to grab a particular item from the list is by that item's index. So what do I actually mean by index? Well, the index is just the item's position in the list. Let me show you what I mean. So if I type prime numbers and open the square brackets, and in between the square brackets, I can put a number, and that number is the value of the index. So let's say I put the value number 2, and when I print out the value and also run the code, then I get back the value 5. But you might be wondering, 5 is the third value in this list. So why is it the third item? Well, it turns out that programmers really love counting from zero. In other words, the first item number 2 is at position 0, 3 is at position 1, and 5 at the position 2. But that may not make a lot of sense to humans, but it actually does to computers. So now, oftentimes we're going to be storing the value that we pull out from a list in another variable. So we can do something like best prime is equal to prime numbers open square brackets 4. So in this case, we are pulling out one of these numbers from the list and also storing it inside the variable called best prime. And I can actually print the value of best prime. And then when I run the code, then we also see that we've actually pulled out the value 11. But let me ask you this. Let's say we have a list of eggs and we want to pull out the egg at index 1. So which egg are we going to be pulling out? Or which egg is my egg equal to? The answer is we would be grabbing the second egg in the list. Now, the reason I'm emphasizing on this point so much is because forgetting to count from 0 is super common. And this off by 1 errors will also crash your Python program. So let's check what happens when we say prime numbers square bracket 5. And when I run the program, then we get an index error, list index out of range. And this is because we are trying to select an item beyond the length of the list. Our list has 5 items and we are trying to select an item from the index 0, 1, 2, 3, 4, and the item at position 5 is the 6th one on the list. And since there is no 6th item, then our Python program goes down in flame. List index out of range. So if you ever see these words in your crash logs, now you know why. So to add another value or a prime number to my list of prime numbers, I will use the append method to achieve that. Then in between the parentheses, I'm going to pass in my number, which is 13. And when I print the list of my prime numbers, then we get to see that the value 13 has been added to the list of our prime numbers. So I want to throw this to you as a challenge. Can you try to figure out how to remove the number 5 from the list? I will give you a few seconds to pause the video and give it a go. Did you have a go? So here is the solution. So to remove the value 5 from our list, I'm simply going to say prime numbers, then use the dot notation to access the remove method. So in between the parentheses, I'm going to pass in the number 5. So now, let's actually print out our list of prime numbers. So I can say print, then prime numbers. And when I execute the program, then we see that the number 5 has been removed from our list of prime numbers, which is pretty awesome, right? But one thing to note about removing elements using this function is if the list contains duplicates of the element you are trying to remove from the list, then Python removes the first occurrence of the value from the list. So we can even try out things like prime numbers.clear. And when I actually print out the list of my prime numbers, then we see that it's actually empty. So the clear function is used for removing all the elements from a list. So we've now come to the end of this tutorial regarding lists in Python. And in the next lecture, we're going to be looking at a different kind of collection, which is called the tuple. So I can't wait to see you there, and as always, take care. Hello and welcome to another lecture on a new kind of Python collection, which is called tuple. So, what is now a tuple? Well, a tuple is just a collection of objects which is in order and immutable. In other words, the elements inside a tuple cannot be changed once they have been assigned, and they are also used to store multiple items in a single variable, just as we did earlier using the Python list. So therefore, let's try to understand tuples in Python deeply, and let's see its application, use cases, and how they are different from the Python list we've discussed in the previous lecture. So to create a tuple, I can create a variable called tuple1, then assign the equal to. And however, a tuple in Python is quite similar to a list we did earlier, but this time around, a tuple is created by placing all the elements inside parentheses. So I can give it a value, let's say 5. So to add another element, we separate them with a comma, and I can also add another value 10. However, a tuple can have any number of elements which could also be of different data type. In other words, it can contain data types such as integers, float, and even strings. So I can add in the string, softlinks, and finally a float value, which I'm gonna say 4.5. So when I print the value of our tuple, which is tuple1, and then run the code, then we see our tuple in the console. But let's actually check to see the type of this variable. And when I rerun the program, then we see that it belongs to the class tuple. So to access the element inside a tuple, we say tuple1. Then, just like the Python list, we use the square bracket and then pass in the index, which I'm gonna say 1. And when I print the value and also run the code, then the second element inside our tuple got printed out on the console, which is 10. And when I also pass in another index, let's say 5, and rerun the code once again, then we get an index error, tuple index out of range. So as I mentioned earlier, this is because we are trying to select an item beyond the length of our tuple. So now, let's actually check out some of the few methods associated with tuples. So I can erase my square bracket here and then use the dot notation. So let's use the index method. However, we actually use the index function to find a particular value inside the tuple, and then in return we get the index or the position of that given value from our tuple. So in between the parentheses, I can pass the value 4.5, and when I run the code, then we see that we get the index value of 3 as the position of the 4.5 from our tuple. Another function is also the .count method. So the count method returns the occurrence of a specified value in our tuple. So I can give the value 10, and when I run the code, then we see that the value 10 appears once in our tuple. So let me actually introduce you to something even cooler when working with tuples. The thing is, we can actually change the data type of a tuple in Python. In other words, we can convert this tuple here into a Python list. So to illustrate, I'm gonna say list, then in between the parentheses, I'm going to pass in the variable tuple1, and I can also set the whole thing to a variable tuple to list. Then finally, I'm going to print my tuple to list variable, and when I run the code, then you see that we get back a Python list. And when we check the type of this variable, we also see that it belongs to the class list, which is pretty awesome, right? So however, the same principle with the tuple, we can also change the data type of Python list into a tuple. So let's see how. I'm going to create a list of numbers called num and set its value to square brackets 1, comma, 2, and then 3. Then I'm going to say list tuple is equal to tuple, then parentheses, and then pass in my num variable. Then finally, let's say print parentheses, then give my list tuple variable. And when I run the code, then we see our list has now been printed out as a tuple. And when we say type and rerun the code, then we see it's of class tuple. So we've come to the end of this tutorial regarding tuples in Python. And you learned how tuples are immutable and also saw how it stores multiple data types like floats, integers, and strings. And finally, how we converted a Python list into a tuple, also converting a tuple into a Python list. So in the next lecture, we're going to be looking at conditional statements in Python. I'll see you in the next lecture. Take care. So now that you have quite a bit of Python code under your belt, however, let's now talk about conditional statements in Python. A conditional statement, as the name suggests itself, is used to handle conditions in your program. These statements guide the program while making decisions based on the conditions encountered by the program. To give you a realistic example, oftentimes in our daily life, we need to first see the condition and before making a decision. So consider that a biscuit costs $10 and a piece of chocolate costs around $5. So you can say if you have at least $10 in your pocket, then you buy the biscuit, or else you will buy a chocolate that costs less than $10. However, in Python, we use the conditional statement to perform this sort of decision making. So before diving right into if statement, first, I want you to understand something important, which is comparison operators. We use comparison operator in Python to compare values of two entities together, and in return, we get back true or false based on whether the condition is met. So let me show you. Here inside my VS Code terminal, I can say Python 3. And if you are on a Windows machine, all you need to do is to type in Python instead of Python 3 and then press enter. So as I mentioned earlier in my previous lessons, this is actually called the Python shell, which is part of the Python integrated development environment. And the three greater than signs here are called the prompts, which, as you can see, it's actually ready to accept Python comments. So I can say 20 greater than 5. And when I hit enter, then I get back the value true. So in Python, this expression we gave here is called a Boolean expression. And in return, we get back a Boolean value, which could either be true or false. So here is another example. I can also say 20 is greater than or equal to 10. And when I hit enter, then we also get another Boolean value, which is true. Again, we also have less than. So I can say 20 is less than 5. and at this time we get false. Then we have 20 is less than or equal to 40. We also get back true, and we also have the equality operator. So 30 is equal to 20, which is false. And finally, we have the not equal to. So 20 is not equal to 10. And we get the boolean true. So now that you've understood the comparison operators, let's actually start by looking at the most basic type of if statement in its simplest form. And to exit from the Python shell here on the terminal, all you need to do is to press Ctrl plus Z. So back to my code editor, I'm simply going to create a variable called cache and set its value to 5. Then I'm going to say if cache is less than 10, column, and then print buy chocolate. So the if statement is made up of the if keyword, and this is used to create our conditional statement. In other words, this if keyword is how you perform your conditional decision making, then followed by a condition. And a condition compares things together and tells us whether the comparison is either true or false. So for example, I'm using the less than comparison operator and also end our condition with a column. And at the next line, Python automatically added an extra spaces before our print statement. And this is called the indentation block. So in Python, the lines after the column must be in a block or indented because it tells Python interpreter what statement should be executed when this condition is true. However, we can read our if statement as if cache, which is 5, less than 10, then print buy chocolate. So when I run the code, then we see that buy chocolate has been printed out on the console. So one thing to note here is that Python prints buy chocolate only if our condition is true. So in this case, cache, which is 5, is less than 10, and this statement or condition is true. So in return, we get back buy chocolate. Now let's see when we change our condition. So instead of less than here, we say if cache greater than 10, then when I run the code, then we get back nothing. And this is because our condition is false. 5 is not greater than 10. So as I mentioned earlier, the if statement only executes a block of code only if our condition is true. So again, I can also say if cache not equal to 10, which is true, then print buy chocolate. Perhaps we can also print other choice of messages as well. Let's say hello softlinks. Also print how are you. This block of code is made up of 3 print statements that run only if our condition cache not equal to 10 is found to be true. And when I run the code, then I see my messages printed out on the console. And this is because our condition cache not equal to 10 is found to be true. So now, let me actually introduce you to the else conditional statement in Python. We use the else keyword to decide what to do if the condition is actually false. Let me actually show you how. If I change my condition here to double equal to, however, Python won't print this 3 statement because our condition is false. Cache is actually not equal to 10. So I can now add my else block here and I can say else, then a column. And when I press enter, then we also get to see that Python also indented our code. So I can say print I am fine. As we all know, our condition here is false. And when we run this program, then we're going to get the message, I am fine. However, same with the if block, I can also add other statements inside the else block. So I can say, print, my name is Shuaib. Finally, I can also say, print 5 multiplied by 5. And when I run the code, then I get back my 3 print statement printed out on the console. Again, a popular mistake I see most beginners make is wrong indentation. So for example, if you have an extra space in any line of either your if or else block, then your program will crash with an indentation error, unexpected indent. And as you may observe, Python highlighted the line where it sees the problem with the red line. So you want to make sure that you indent your code properly in Python. In addition to using if statement, we can add multiple conditional expressions. So what do I mean by multiple conditional expressions? To illustrate, I can create a variable called money and set its value to 100. Then I can also say if money is equal to 100, print I am rich, or else column print I am poor. So we can extend our if statement even further with elif keyword, which is short for else if. In Python, we use the elif condition to include multiple conditional expressions after the if condition. And same with the if block above, Python executes the elif keyword only if the specified condition is true. So I can say elif money is equal to 80, column, then print I am happy. And I can also add another elif block. So I can say elif money is equal to 60, column, then print you are nice. So when I run the code, then we get the statement I am rich. And this is because our condition is true. The value inside the money variable, which is 100, is actually equal to 100. And the rest of our condition below is false. And when I change the value inside money to be 80 and also run the code, then we get back I am happy. Again, when I change the value from 80 to 60 and rerun the code once again, then we also get back the value you are nice. However, what Python does here is that when we execute the program, it actually checks our first if statement here to see if the value inside money variable is actually equals to 100. So in this case, the value is set to 60, which is false. Then Python jumps into the next if statement to see if the value inside money is equal to 80, which is also false. Again, it jumps to the next if statement. So at this point, the value inside money variable is actually equal to 60. Then Python will print our statement, you are nice. However, let's say I change the value inside money to be 20. And when we run the code, then we get back the statement, I am poor. And this is because none of our condition inside the if statement is actually true. So in essence, Python executes the else block, then we get back the value I am poor. So now, let's talk about something even cooler, which is combining conditions. In Python, you can combine conditions together. So for example, I can say if money equal to 100 or money equal to 80 or money equal to 60, column, then print I am rich. Else, column, print I am poor. So when I change the value here to 80 and then run the code, we get I am rich on the console. So Python checks if any of the conditions on this line is true. In other words, if the value of money is equal to 100, 80, or 60, then the print statement here will execute. And if all the conditions are actually false, let's say I change the value of money to 20, then run the code, then we get the statement I am poor. So we've now come to the end of this tutorial. However, you learned how to work with if statements to create blocks of code that are executed only when a particular conditions are true. You also saw how to extend if statement with different conditions using the elif, which is short for else if. Then we also learned how to use the else keyword to execute code if none of the condition turned out to be true. And finally, combining conditions using the OR operator. So in the next lecture, we're going to be looking at loops in Python. So I can't wait to see you there. Take care. So in this lecture, we're going to be looking at loops in Python, as well as the types of loops that Python offers. However, nothing is worse than having to do the same thing over and over again. Meanwhile, programmers don't particularly like repeating themselves either, unless they are also trying to fall asleep. Thankfully, most programming languages have what is called a for loop, which repeats a specific block of code a number of times automatically. So for example, let's say you want to print hello 5 times. Then you could be doing the following by using the print function 5 times. But this is rather tedious. Instead, we could use a for loop to reduce the amount of typing and repetition. So we can say for x in range, then parentheses 0, 5. So we can use the column to terminate our for loop, then press enter. As you can see, we get an indentation. So in this block, we write the code that will be repeated inside the loop. So I'm gonna write print hello, and when I run the code, then we get to see that hello has been printed out on the console 5 times for us. So we use the for to start our loop in Python, and the x here is a temporary variable used to store the integer value of the current position our loop is iterating. So we can use any other variable name of our choice in place of the value x. And one thing to note is that the variable x is limited to the scope within the for loop, meaning we cannot access the value of x outside our for loop. However, the range function here is used to create a list of numbers ranging from a starting number up to an ending number. So our range function in this for loop is actually telling Python to start counting from 0 and stop before reaching 5. And for each number we count, Python should store the value in the variable x. So inside my print statement here, I can also print hello with the value of x using formatted string. Then I'm going to add my curly bracket and then pass in the variable x. And when I run the code, then we get hello with each value of x printed out on the console, which is pretty awesome, right? So as you can see, Using the for loop has actually saved us from writing too much lines of code because good programmers hate doing things more than once. So the for loop is one of the most popular statements you often see in programming languages. Meanwhile, you actually don't need to stick to using the range function when making for loops because we can loop over different kinds of data types in Python like strings, lists, tuples, and so on. So for example, I'm gonna create a variable called name and set its value to the string Adam. And on my for loop, instead of the range function, I'm simply gonna add name and then finally print the value of x. And when I execute the program, then we see that Python iterates over our string Adam and print out each of the iterative value for us on the console. However, instead of using a string, let's try out using a Python list for our for loop. So I can select my text here and add the square bracket. Then I'm going to add another name. Let's say Schweib, comma, and then Khalid. I'm also going to change the variable name here to names. So on my for loop, I'm going to say for x in names variable and then run the code. Then we see each individual names printed out for us. And as I mentioned earlier, this code is a way of saying to Python that for each item inside our list of names, store the value in the variable x and then print the content of that variable on the console. Furthermore, as I mentioned earlier that we can loop over different kinds of data type in Python, now let's actually use the for loop with a tuple instead of a Python list. So I can change my square bracket with parentheses. Now we have a tuple of names. Finally, in my print statement here, I'm gonna use the formatted strings. So when I add double quote and say hello, curly bracket, and then pass in the value of x, and when we run the code, then we get back hello with each of the value inside our tuple. So now let's talk about another kind of loop in Python, which is called the while loop. As we all know, a for loop is a loop for a specific length or number of iterations, but a while loop is a loop that is used when you don't know ahead of time when it needs to stop looping. So for example, I want you to imagine a staircase with 15 steps. The staircase is indoors and you know you can easily climb 15 steps to get up the stairs. However, this is an example of a for loop. But imagine a staircase going up a mountain. The mountain is really tall and you might run out of energy before you reach the top. Or maybe the weather might turn so bad, thereby forcing you to stop climbing. So this is actually what a while loop looks like in real life. Therefore, let's now create a while loop in Python. So I'm going to start by creating a variable called num and set its value to 5. Then we're going to use the while keyword in Python to create a while loop, then followed by the condition. I'm going to say while num is less than 10, column, then print my endless loop. And when I run the code, then my loop keeps printing out the value my endless loop on the console. And this message won't stop printing out on the console as our program keeps running. So to stop the program from running the loop, all you need to do is to press Ctrl plus Z. However, let me show you something even cooler. After my column here, I can update the value of num variable. So I can say num equals to num plus 1. And when I run the code, then we get back the message printed 5 times on the console. So our loop started counting at 5 for the variable num. And at this line, we increment the value of num by 1 every time the loop runs. And when the value of num has incremented to 10, thereby making our condition to become false, then the loop stops printing our message on the console. Now, let's talk about a key concept that you need to understand when working with loops, which is called nested loops. A nested loop is a loop statement inside another loop statement. In other words, the inner or outer loop can be of any type, such as a while loop or a for loop. And that is why nested loops are often called as loop inside loop. So to implement a nested loop in Python, I'm going to start by creating a variable called items and set its value to a Python list. So in Python, we can create a list whereby each element inside the list is also a list by itself. To illustrate, I will add another square bracket for my first list and pass in my first item in the list in the form of a string, which is red, comma, then pink. I'm also going to add a comma, then another square bracket for my second list. This time, I'm going to give it the item berry, comma, then grapes, and another comma for my next list. So square brackets, then cat, comma, and dog. So as you can see, we've now created a Python list, and this list is also containing a list of individual items. So to print the item inside our list, I'm gonna say for item in items, then column. So remember that the item here is my temporary variable for looping over the list. So I'm gonna say print item, and when I run the code, then we get back 3 lists stored inside our items variable. So to also access all the elements inside this list, I'm gonna erase my print statement here and then add another loop. So I'm gonna say for x in item. Again, I took a temporary variable x for each of the elements inside item, then column, and then print the value of x. And when I run the code, then we get back all the elements printed out on the console, which is pretty awesome, right? However, I want to pose this to you as a challenge. Can you try to figure out how to print out this multiplication table on the console for us? I will give you a few seconds to pause the video and give this a go, and come back for the solution. So did you have a go? Here is the solution. I'm going to create a for loop for I in range from 1 to 13, then column, and then another loop for x in range also from 1 to 13, then column. So now I'm going to say print using formatted strings, add a curly bracket, then I, multiply by another curly bracket, x, then equal to last curly bracket, I multiply by x. So out of the inner loop, I'm gonna print this piece of string. However, our first loop here is counting from 1, stopping at 13, and our second loop is also counting from 1 to 13. Then we printed the value of I and the value of x, and then multiplying both the value of I and x together. And when I run the code, then we get back a 12 times multiplication table printed out on the console for us. So we've now come to the end of this tutorial regarding loops in Python. First, you learned about using for loop, also while loop and nested loops in Python. Then you also had a challenge and saw how to use nested loops and generate a multiplication table on the console. So in the next lecture, we're going to be looking at how you can recycle your code using functions in Python. So what's now a function? That's the mystery we're going to be exploring in the next lecture. I can't wait to see you there. And as always, take care. In this lesson, I'm going to be introducing you to the cornerstones of programming, namely functions. Well, functions go by many names. In other ways, functions are being called procedures or methods. But don't let the jargons get you. The central idea is always the same. And on that note, I hope you are ready to learn about functions. My goal in this lesson is to explain exactly what's going on a line of Python code like this. Upper followed by the parentheses. We're going to be focusing on the part after the dots because that way we can break down the programming concept behind functions into bite-sized lessons and build up the big picture. As such, this lesson really set up the next couple of lessons on arguments, return values, and on objects. So the question is, what's so great about functions? Well, imagine I'm a little housekeeping robot, and if I was a human, you could tell me, hey, go and buy some milk. That instruction will make sense to a human because a human will understand what to do in order to complete this task. However, when we are giving instructions to a robot, it doesn't quite work like that because a robot doesn't know what is involved in getting a milk, especially a robot with no machine learning capabilities. So, if you are dealing with a robot, you have to specify every single step of this task, like taking the money, opening the door, closing the door, walking to the store, etc., etc. You as the programmer have to specify every single instructions. Now come the next day and you need to get some more milk. Well, you have to specify all of these instructions again, and that would be incredibly annoying. So here is where functions come to the rescue. With function, you can bundle all of these individual instructions into a single instruction. And we can also give this function a descriptive name, like get underscore milk. Now, every time you want to use get milk, the housekeeping robot knows exactly what to do because it will execute all of these instructions contained inside this get milk function. So, there is something to note here. What we just described is actually a two-step process. First, you have to tell the robot what get milk means. And second, you have to tell the robot to execute this get milk instruction. In other words, the first one is defining or declaring the function. And step 2 is using or calling the function. So the syntax looks like this. When defining the function, you often see the keyword def, then followed by the name of the function, followed by parentheses, followed by a colon. And after the colon, on the lines below, we have the instructions inside the function. This group of statements is going to be indented, and the indentation tells us what statements are inside of the function. Now, while you and I have a head and a body, a function also have a header and also a body. And the header is the line right here, the line with the def keyword at the top. And the body are all the statements or instructions that are inside the function. And basically all the lines are indented. That's the body. So now that we know a little bit about what a function is supposed to look like, let's now create our own first function. So we can write def get underscore milk and then parentheses followed by a column. And when we hit enter, we get taken to the next line, which is indented. So we can print out some instructions like open the door, and on the next line, which again is indented, and follow with some more instructions that are gonna be inside the function, like print walk to the store, and then print buy milk. And we're gonna be finishing it up by printing return home with milk. So in our function body, we have 4 individual print statements. Notice that Python indented these 4 lines of code for us. So we have indentation of 1, 2, 3, 4. In Python, this indentation or white space actually matters quite a bit. Indentation in Python is like a full stop at the end of English sentence. So just like the full stop at the end of a sentence, the white space helps Python determine when one instruction ends and the other one begins. Usually, the code editor that you could be working with, either a VS Code editor in this case, will help you indent your code correctly. So let's actually run the code and see what happens. So we get nothing at all, right? And this is because we've only defined the function. We actually haven't executed it yet. So let's call the getMilk function now. Get underscore milk. And when I run the code, then we see the first statement printed out on the console for us. So see you in the next lesson. Take care. Now that we've covered the function basis, let's now talk about parameters and arguments. So I realized that if you are new to programming, you're gonna be hearing a lot of new words in these lessons. And one thing I will say is that when you are learning anything new, the hard thing isn't necessarily the concept, it's often the language. And it doesn't really matter if it's programming, medicine, or even cooking. Every field have its own jargon and its own words. So a big part of learning Python programming is learning some of these vocabularies. I'm going to be doing my best to introduce you to these vocabularies slowly over the course of these lessons. Looking at the code we've written previously, we will see that functions take inputs. So for example, this index function here had an input of 4.5, and our count function here had an input that was an alphabet in the form of a string. And all of these inputs to the function go in between the parentheses after the function name. Our getMilk function had no inputs, and this is the same with the upper function, which also has no inputs. In contrast, this count function has a piece of text between the parentheses, and this piece of text was the input to the function. These inputs are called arguments. So let's create our own function that takes an input. That way, we can put all of this into practice and see how the code actually works. So I'm gonna modify my code of getMilk function. Inside my parentheses here, I'm gonna specify an amount. And this amount is gonna be our input to our function. Finally, I'm gonna modify our third print statement down here. So I'm gonna use formatted string and then use curly bracket here where it says by, and then embed the value of amount. So let's call this function to see it in action. Down below my code here, I'm gonna say get milk, which is the name of the function, followed by the parentheses, and then within the parentheses I'm gonna put single quotes and then 5. And when I actually run the code, now we see that the piece of text we've entered between the parentheses shows up in our print statement. So let's call this function again, but this time with a different amount. And instead of the string here, I'm going to pass in an integer value of 10. And when I run the code, then this time around, we get back our message with the value 10. Now, let's look at this code and think carefully about what's going on. Our getMilk function takes one input, and that input has a name and it's called amount. But the real cool part is how amount is just a placeholder. The value of amount is determined by whatever we specify when we call our getMilk function. In other words, amount behaves just like a variable. It gets its value when we call the function, and every time we refer to amount in the body of the function, we are able to use the value that is stored inside. Now, there is two other things that you might notice about the code we've just wrote. First, let's try to call this function with empty parentheses. And when I execute the code, then in this case, we get a type error. And the details of this error message reads, missing one required positional argument, amount. In other words, because we've defined our function with an input, so we must provide it. We specified one parameter in the function header, so we must give a value, because we can't just leave it out. The other thing that you'll also notice at this point is that print is nothing than a function as well. Print takes a piece of text as an input and print it out on the console. So if print is a function, then that means we are calling a function inside our function. So now, here is a quick recap. When working with functions with input, we specify what the input is upfront beforehand when defining the function. The input is specified between the parentheses following the function name. In this example, the input is called money, and money is just a placeholder. In programming jargon, when referring to input as a placeholder or a variable, we tend to call it a parameter. As in, getMilk has one parameter called money, and when we call the function, we must provide a value to this parameter. In this case, we must provide a number, and that number is going to be 20 when I call this function. The value that is passed to a function is being called an argument. Now, oftentimes, you'll see the words parameter and argument used interchangeably, but If you want to express yourself precisely or get technical, then it's good to know these definitions. A parameter is when we are referring to the input to a function that we are talking about it as a placeholder. And we use the word argument when we are talking about the actual value that we are giving to the function when we are calling it. So we've covered quite a few different kinds of functions so far. For example, we've understood the syntax behind upper, and we also understood the syntax behind count or index. Upper has no argument, but the count and index has an argument. Now, we're going to be looking at functions with multiple arguments. We've actually encountered multiple arguments when we call the replace function for replacing the letter O with the letter I in our string, welcome to Softlinks. So we can see that these two arguments are separated by a comma. But let's actually create our own function and have it to take more than one argument so that we can see this in practice. So back to getMilk function we've created earlier. I'm now going to modify this function. I'm also going to change the number of parameters that are in between the parentheses. So after amount, I'm going to add another parameter. I'm going to add a destination, and we're going to use this parameter in our second print statement. So instead of printing walk to the store, we use formatted strings and add our curly bracket here. Then pass in our destination, which means we're going to concatenate whatever is passed in as destination and then print it out on the console. So let's try out our function. In getMilk, when we call the function, for amount, I'm going to pass in 20, then comma, and for destination, I'm going to write in single quotes, main store. Here we can see that our first argument, which is 20, and our second argument, which is destination, in a string. And when I run the code, then we see that these values were substituted in our print statement accordingly. Now, here is the question. What do you think will happen instead of saying getMilk 20 main store? We write getMilk main store then 20. And when we run the code, then we get walk to 20 by main store milk. So what this tells us is that our arguments to our function are passed by their position. In other words, the order in which we give the input to our function matters. The arguments are passed from left to right. So as before, we must supply exactly 2 arguments when we are calling getMilk. But we also must be careful to supply this argument in the right order. Looking at the syntax for calling a function, one important thing to note is that Python provides an alternative for passing arguments by their position. We can also match our arguments by providing a name. In other words, we can add the name of our parameters to the function call so that Python will match its value by keywords. So if we say destination is equal to main store and amount is equal to 20, and when we run the code, then we can see that the output on the console updates to the way we want it to be, namely walk to the main store, buy 20 milk. So here we are setting the destination equal to main store and we are setting amount equal to 20. But let me actually show you this. If we say getMilk and then pass in 20, then comma, destination equals to main store. And when we run the code, Then in this case, the argument 20 is set by position and the destination is set by name. Now, the thing about named argument is that they make the Python code much more readable. It's like having the labels for the data. But let me ask you this. What do you think will happen if we call our function like this? Get underscore milk, parentheses, main store, comma, amount equals to 20. When I run the code, then we see that we get a type error. And the reason is that we are trying to assign a value to amount twice. The first time we are assigning the stored value to amount because Python is evaluating our argument by their position. And the second time we are setting amount to 20 by using the keyword. Okay, cool. We've now come to the end of this tutorial on functions, parameters, and arguments. And we've covered a lot of material here. And this material will sink in more with practice, I promise. So, see you in the next lesson. Take care. Functions that execute a bunch of code are very awesome. But often, we want to get back a value back from a function. In this lesson, we're going to talk about how functions return a value and get the result back. Returning a particular value is actually why often we call a function in the first place. The reason why we are calling the index function here is because we want to pass a value which is 4.5 and get the index of that particular value as an output and also store that data in a variable. Let's actually look at the mechanics of returning values more closely in our getMilk example. In this case, we are supplying an amount of money as an input, and we are using our input to make a calculation. In other words, we are dividing the amount of money by the price of milk to calculate the liters of milk to buy. So the question is, how do we return the result of this calculation? And the answer is, we use the keyword called the return keyword, then followed by the value that we want to return. We write return liters. And that word return is actually a Python keyword. When Python hits this line of code that says return, it will exit the function and will return whatever result that comes after that keyword. So in our case here, getMilk is outputting the value inside liters, and the call to getMilk is actually the same as before. We have the function name and a value for an argument, say 20. However, if I run this program, then we get back nothing because our function is returning a value, but we are not storing the value anywhere. So what you will typically find is that when a value is returned by a function, then we're going to be storing that value in a variable. So enough for the theory. Let's now put this into practice. Suppose you are working for a cutting-edge Silicon Valley company and you are building a calculator. You are the engineering lead at the team and have been assigned incredibly important tasks of programming the multiplication button. As a challenge, can you do the following? In your code editor, create a function called times and have this function text to input. It needs to multiply this input together and provide the result as an output of the function. Also, you need to test this function that it actually works. So call your function and multiply 3 by 5. Store this value in a variable called answer and print out the value of answer on the console. I will give you a few seconds to pause the video and give this a go. You ready? So here is the solution. So the first thing we're going to do is to define our function. We're going to use the keyword def. We're going to give our function a name. We're going to call it times. Now we will provide two parameters. Let's say x and y. Well, you can call these parameters anything you want, by the way. We then have the column. Hit enter and say we want to store the answer of the multiplication in a variable. So we say answer equals x multiplied by y. And then to output the value of this function, we go with returned answer. Now, suppose you called your parameters a and b instead of x and y. Then you have to be consistent. You need to have a and b inside the body of your function as well. So now that I'm done with my function, let's actually test it. So I'm going to type times 3, 5. However, we said we're going to store the value from the function inside a variable. So let's say result equals to the times function. And when I print the value of result and then run the code, then we see the value of our multiplied variables printed out on the console for us. Now we can actually simplify the code inside our times function a little bit. In fact, we actually don't need this extra line of code here. So I can comment it out with a hashtag, and instead of returning answer, I can return the calculation directly. I can say a times b. And when I run the code once again, then we can see that our function is working and our output is the same. If you've decided to write your function just like this, then you are doing the calculations on the same line as the return keyword, and this is absolutely fine. Now let's continue our story on working at Silicon Valley Tech Company, and I want you to connect this lesson with our previous lesson on data types. Now that you've written your function and submitted your calculator code to the project team, and a moment later your boss comes in and type single quote me, comma, then 5. And after typing this to your code editor, he smiles and then walk away. So let's see what will happen when we run the code. If we actually run this code, then we see the word me displayed 5 times on the console. So this is unexpected, right? The times function does completely different something now. That multiplication symbol is not multiplying when we are passing in a string. The multiplication symbol, in fact, is repeating a sequence. And what this shows is that the Python code doesn't really care about the specific data types it's running on. In this case, both numbers and strings support this times symbol. Now, what this means in practice is that we developers, when we are writing our Python code, we need to have some tests and be aware of the kind of data type that we are working with, and also to detect errors. A reasonable question to ask as well is, Python is really about flexibility. Ideally, Python code should not really care about the types, and this is in contrast to other programming languages like C++ or Java, because Python is meant to be flexible. This is core part of the Python philosophy. In fact, returning to our topic on function, this is a good time to review and summarize the three flavors of functions that we've encountered so far. We've seen functions with no input and no output. We've seen functions with input, and we've seen functions with both output and input. When defining a function, we always have to use the def keyword. Then the name of the function, followed by the parenthesis, and then the semicolon. Also, the very important thing is that the body of the function is also indented. I recommend using 4 spaces, but most code editors will indent this for you automatically. Finally, we've encountered functions that have both input and output. The key thing here is that functions with output have a return statement. The output is whatever comes after the return keyword. And the way to remember this is that in the future, if you ever dating a programmer and you tell them to go to the supermarket and buy some milk and they never come back, then this is because you haven't told them to return anything. So this wraps up our tutorial. But however, one thing that developers have learned over the past few decades is that splitting up a task into smaller or manageable parts is really important, and it helps a lot. On a small scale, the splitting up of different functionality is accomplished by putting code into functions, and this is accomplished by splitting up bits of code into different files. The rationale behind both of these strategies is the same. They are about managing complexities. And on that note, I want to leave you with something special. In your code editor, type import this and then run the code. You will be greeted with the Zen of Python by Tim Peters. My favorite lines are simple is better than complex, and complex is better than complicated. And on that note, I'll see you in the next lecture. Take care. In this lesson, we're going to talk about import statements, modules, and packages. Import datetime, import random, and import pandas as PD. These are the import statements that we're going to talk about in detail in this lesson. Each of these import statements imports a Python module that we can then use in our VS Code editor. If you've already got some experience in programming, perhaps in other languages, the easiest way to think about Python modules is as frameworks or libraries. This is what they're going to be called in other languages. When you actually click on the Explorer tab here, then you're going to see that our Python file is actually a .py file. And the simple way to think about Python module is that every file that ends with .py is actually a Python module. And by importing a module, we get access to the variables and the functions inside the file that was imported. In other words, importing gives us access to a .py file content. So to illustrate, I'm gonna create a new Python file. Let's call it life, and then append a .py extension and then hit enter. Now that we've got our Python file created, let's create a variable called the answer and set it equal to the number 42. Then all you need to do is to press Command plus S or Control plus S if you are on a Windows computer to save your code, or click on File here, then make sure Autosave is selected. Now that we've created our Python script as a .py file to our programs folder, then we can start using it. Back to our app.py file, we can write import life. Now, because I have an irrational love of data types, let's actually check out the type of this thing called life. So I'm gonna write print, then say type, and then put life in between the parentheses. When I run the code, then we find out that our life.py file, when we imported it, is called a module. So here comes the really cool part. We are actually going to access the code inside our life module. So we're gonna say life.theAnswer. Then I'm gonna store it in a variable called value. Finally, we're gonna print our value and then hit the run button. How cool is that? I think this is super cool, right? It's like our Python file has finally made a new friend. But let's take a second to think about what this line of code actually means. It actually means we are fetching the value of the answer that lives inside the module called life. And the thing to note here is the Python syntax. We've accessed the variable inside life.py file using the dot notation. In other words, we've accessed the answer by writing life.theAnswer. And this dot notation will come up again and again as we progress throughout the course. So now that we've just created our own module and then imported it in our file, let's take a look at this code right here. Import datetime and also import random. Well, in this case, we actually didn't have to create any .py files. We just wrote import datetime and then it worked. So how is it that we can actually do that? See, I used to think it was magic, but then sadly I discovered that it was in fact not a magic, because it turns out that when we install Python on our computer, a whole bunch of modules were already included in our installation. And this is why there was no need for us to create any datetime or random.py files to our project folder, because Python already knew about datetime and random. But the question is, what kind of other modules that Python already knew about? So let's take a look together at what kind of modules we have access to out of the box from installing Python. We can get hold of this information in various places. The first place we're going to check is the Python documentation. So here are the modules that are built into Python language itself. And this built-in modules is also the so-called Python standard library. And however, there are over 200 modules here. Scrolling around here, we can see that there is one module called math. So let's take a closer look at this math module. Well, the math module is something that you can use to do all sorts of calculations. And this module actually has information on two things, namely the value of pi and the number e. So as a challenge, can you import the math module to your code editor? And after you've imported the math module, write the Python code to print the value of pi on the console. And after that, write some more code to print out the value of e as well. I will give you a few seconds to pause the video and give this a go. And here is the solution. So, just like we've imported datetime, we simply write import math. And to get the value of pi, I can write math.pi. Then print the value of pi. Then hit the run button. And here is the value of pi from the math module. And looking at the official Python documentation, we can see that we can access the value of e using the code right here. So in my code editor, this means I can simply write print math.e and also run the code to complete the final part of the challenge. That's pretty cool, right? So using the math module and the dot notation, we can access any of the variables inside the module through their name. And this is exactly the same syntax that we used earlier when we created our own .py file. And access the answer by writing life.theanswer. And this shows that we can access a lot of code from other modules, like the math module, using the same dot notation. Now let's take a look at this import statement. Import pandas as PD. Well, this import statement that you just wrote with pandas is a little bit more complex than the one we wrote with import math or import life. So the pandas import statement had something a little extra. We wrote import pandas as PD, and Python is highlighting the as in orange color. However, the syntax highlighting is telling us that the as in this line is a Python keyword. So what does this as PD actually does, and why is it there? So the answer is, all what as PD is actually doing is giving us an alias to the import statement. So why do we actually need an alias? Well, when you think about it, the module math only has 4 letters, and you don't need a lot of typing because it's pretty short. But this module pandas has about 6 characters. So we actually don't want to type out 6 or more characters every time we are referring to pandas. So instead, we wrote import pandas as PD. And this created a variable called PD, which referenced our pandas module and allowed us to use a short name instead. So PD became the alias for pandas. And we can call it anything we wanted, by the way. We can even call it Shuaib or you. So now that we've talked a little bit about the as keyword to create an alias, let's actually put it into practice so that it really sinks into our memory. We're going to use the as keyword with our life module. So check this out. If we write import life as Shuaib, and when I run the code, then we get a name error. Name life is not defined. And this is because we also have to update the code here. And the reason is that we can no longer refer to this module as life because we've given it an alias called Shuaib. So when I type in Shuaib and then rerun the code, then our error now disappears. Now I hope this exercise made it a bit more clear as how the as keyword works in practice. So let's talk about another kind of import statement in Python. When I say from life import the answer, then I will delete this code right here and write print, then pass in the answer. And when I run the code, then I still get the value 42 that lives inside our life module. Now, a very reasonable question that you will probably want to ask at this point is that, How is this different from the other import statement? And why are there three ways of importing things? Can't we just keep things simple? Well, the three import statements are all doing very similar things. And the reason I'm showing you these three ways of doing things is because people out there in the world are using these three ways of importing modules in their Python code. And the difference to the other import statement that we've used earlier is that in this case, we are copying out the answer from our life.py file. The answer is now its own variable inside our Python code because we've just made a copy of it, and this means we can also do stuff with it. So for example, we can create another variable called name and set its value to the string soft links. Back to app.py, I can say from life import name and then print out the value of name. Then when we run the code, we see that soft links has been printed out on the console. So in summary, the from keyword copies out soft links as name from our life module and then makes it accessible as a variable inside our current Python file. Now we are slowly coming to the end of this lesson on modules, packages, and imports. And we've covered quite a few import concepts here. So let's review them before we move on. We've learned that Python scripts live inside files ending with .py. And we also saw how we can import existing code as a Python module into our Python code using these import statements. We saw that there are a couple of different ways we can import a module in Python. The simplest way is just to import and then the name of the module. So for example, import math. The next level up was using the ask keyword in the import statement. So in this case, we import the module, but we create an alias as the new name of our module. And we use this name to refer to it later. Finally, we saw how we can use the from keyword to copy out a specific piece of code from another module. And this is what we did to get from life import the answer. So at this point, I suspect that you've probably already started to see the power of this import statement and how they are a massive game changer, because by importing a module, we can use other people's code, and this saves us work from having to write the code ourselves. So on that note, I'll see you in the next lecture. Take care. In this lesson, we're going to combine our knowledge of functions with a new topic. This is called objects. Objects are the basis of every Python program that you will ever write. When programming in Python, we do things by calling functions. I mean, functions that add two numbers or functions that import data. You see, pretty much everything in Python is an object. Remember those two modules that we talked about in previous lesson? Modules like pandas, math, or our own life module. Those are objects. More formally, all the data in Python take a form of object. And the goal of this lesson is to explain the code that we wrote in previous lessons in more detail. By the end of this lesson, I want you guys to have a deeper understanding on how life.theanswer and math.py actually works. My goal is to make these lines of code make a lot more sense. Let's make a real-life analogy to objects in Python. Suppose you have a car, and we're going to talk about your car like a Python object. First, your car needs to have a name. We are actually going to call your car a Rolls Royce, all lowercase and with an underscore to keep the Python naming conventions. Now, if you have to describe your car to your friends, You might talk about your car color, the number of seats it has, and the power of the engine, or how much petrol you have left in the tank. All of these things are attributes of your car. Now, there is something quite significant about this, namely, these attributes capture information about the state of your car, and your car state can change. For example, as you are driving along, the amount of fuel in the tank will decrease. In the same way, if you've got a computer game, the state of the game will also change. Most obviously, the level that the player is on will change as the game program runs. But coming back to these attributes, let's talk about these attributes in a bit more detail and look at the Python syntax. The thing is, much of the Python programming boils down to this simple pattern: object.attributes. So if you are writing a piece of Python code and then assessing the attributes of your car, then you might write something like Rolls-Royce.color or Rolls-Royce.engine power. The point is that we also use the same object.attribute pattern when we were talking about our own Python modules with life.theanswer and math.py. In all of these cases, we were able to access information from inside our object using the dot notation. Now, accessing information from objects through their attribute is very well and good. But remember, this is where our functions comes in, because we are going to use a different word to refer to functions in this context. Functions that are used with an object are called methods, and oftentimes you will hear the word function or method used interchangeably. So it is still a good idea to get familiar with all of these vocabularies, because you will definitely come across these words online. And also, nobody enjoys getting corrected by strangers on the internet or in an online forum. So use methods when you are talking about functions that belongs to an object. Back to our car example. Now, the state of the car object is captured through the attribute of the car. And attribute is a piece of information about the car, like the car's color, the number of seats it has, and the amount of petrol. And the most interesting thing about a car is not its features, but definitely its behavior and what the car actually does. And things get done by calling methods. And methods are the name for functions that belongs to an object. So an example of a method on our car object would be something like drive. Now the question is, how do we call one of these functions that is associated with our car? Well, the format is exactly the same with the attributes. We use the dot notation. In other words, we have our object, then dot, and then the name of the method. So for example, if your Rolls-Royce car can drive, then we would write Rolls-Royce.drive. And if your car can do other things like talk, then we would follow the same pattern. So that's enough theory. Let's put this into practice and add a function to our life.py file. In here, we're going to create a function by using the keyword def, and we're going to call this function quotes_Einstein. Our function is not going to take any argument, so we would just put empty parentheses and then a colon, and inside the function we would put a print statement. We're going to print out a single sentence. We're going to have two single quotes, and then we will write, the true sign of intelligence is not knowledge but imagination. So back to app, where we've imported life.py. Here is a challenge. If you can call the quote Einstein method, If you call this method successfully, then you're going to see a code from our print statement on the console after you run the code. So I will give you a few seconds to pause the video and give this a go. Do they have a goal? So here is the solution. You would write life dot quote underscore Einstein and then run the code. So remember, to call the quote Einstein method, we first need to use our module object, and in this case, our module has the name life, and we added a dot after life and then write the name of our method. Now, suppose you just try to run quote Einstein on its own without the object, and in that case, you would get an error. Name quote Einstein is not defined. In other words, our Python interpreter doesn't recognize a function called quote Einstein, and this is because quote Einstein belongs to the life.py. It belongs to the module and not our Python app.py file. And this neatly illustrates the difference between a function and a method. To use quote Einstein, we need to have the object and use the dot notation. Now, let's put a couple of past lessons together. You are back as the engineering lead at the calculator company in Silicon Valley, but your company needs to ship its calculator to its first customers as soon as possible. So, it's now time for you and your development team. As a challenge, it's on you to implement the square root functionality of the calculator. Here is what I want you to do. I want you to open that life.py file and then import the math module. Then you're going to try to figure out how to use the Python square root functionality from the math module. You're going to create your own function called square underscore root. And that function is going to take one input and return the square root of whatever that function has been given as an argument. After you are done, then you're going to calculate the square root of 225. I will give you a few seconds to pause the video and have a go with this challenge. So you ready? Here is the solution. First, we're going to import math, and then we're going to create a function called def square underscore root, and it's going to take a single input, let's say x, then column, and then the body of the function. We're going to return the result of the calculation. So the question is, how do we make that calculation? The way we can figure this out is that we're going to search Google for the official Python documentation on the math module. So we're going to write Python math module documentation into Google. The documentation looks something like this, and it's a pretty long page, but let's see if we can find square roots. We can see that the guidance for using the square root in the math module looks like this. We would have to use the math module and then put a dot after it, and then write sqrt and provide a single argument. Let's use this functionality. Back to our life.py module. On the same line where we have our return statement, we're going to write math.sqrt, and we're going to provide the same input or same parameter that we have for our function. So the name of that parameter in our case is x. Now back to app.py, I'm going to say life, then use the dot notation to access our square root function. Then in between the parentheses, I'm going to pass in 225. So let's store this in a variable called answer, and on this print statement, I'm going to pass the value of answer. And when I run the code, then we're going to see that the square root of 225 has been printed out on the console. So congratulations! Now you pretty much know Python. And in the next couple of lessons, we're going to combine our knowledge and connect the pieces together to build a fun project, which is building a calculator app. This calculator software is going to perform some arithmetic like addition, subtraction, multiplication, and division of numbers. For example, 10 divided by 2 is equal to 5. So I hope you are so excited to build this project with me. And on that note, I'll see you in the next lecture. Take care. Welcome to this lecture where we're going to be building our calculator app. And to build this calculator software, we're going to use something called the tkinter package in Python. Tkinter is a standard GUI library in Python, and GUI stands for Graphical User Interface. Python, when combined with tkinter, provides a fast and easy way to create desktop applications for Windows, Mac, and even Linux. The tkinter module includes various controls such as buttons, labels, and even text boxes used in an application. And these controls are going to be called widgets throughout the course of these lessons. Again, creating a GUI application using Python and tkinter is an easy task. So, before we begin, all I want you to do right now is to hit the like and subscribe button. And without any further ado, let's get started. So, inside my programs folder, I'm going to create a new Python file. Let's call it calculator.py and then hit enter. So, the first thing I'm actually gonna do is to import our tkinter module. I'm gonna say from tkinter import star. And you might be wondering about this star here. And what this means is that the import star statement imports all the attributes and methods inside our tkinter module. So for example, if we say from tkinter import button, in this case, we are importing button differently into our Python file. So to avoid this, all you need to do is to say from tkinter import star, meaning the star is going to import all the elements inside our tkinter module. So in this case, we don't have to do that manually every time you want to access elements from the tkinter module. So the next thing I'm going to say is win equals to tk and then win.mainloop. So let's actually run the code. As you can see, we actually get an empty application window. So the tk function here creates an instance of the tkinter, which is our application window right here. And here on the third line where we execute the main loop, the main loop method is what keeps our application visible. So we want to make sure that we keep the main loop running until we press the close button, which exits the main loop. So I can also say win.title and then pass in the string calculator. And when I run the code, then we can see that our application window name has been changed to calculator. Again, we also have win.geometry. Then I'm going to pass in the size 515 times 365 and also run the code. Now we can see that the size of our app window has been modified. So we use the win.geometry function to give the size of our application window. Though we have a defined size window for our application, but we can actually increase the size of our application window like this. And in the case of our calculator app, we actually don't want to increase the size of the window. So to avoid that, I'm simply going to say win.resizable and then pass in the value 0, comma, again another 0. And when I run the code, then we can see that we can't actually increase or decrease the window size of our application. And also,
the maximize button is disabled. So that's pretty much the basis of creating application window in Tkinter. Now let's start building our calculator software. First, we're going to start by creating the input field of the calculator. So I'm going to create something called a frame, and inside the frame is where we're going to add our input field. So I'm going to call the frame function, and in between the parentheses I'm going to pass in our window object, which is win. Then give our frame a width value of 312 and a height value of 50. And we're going to set all of this into a variable called input underscore frame. Then finally, we're going to say input frame dot pack. And then in between the parentheses, we're going to pass in side equals to top. Now that we've actually created a frame for our input field, which is located inside our window object, so now we're going to create our input field inside our frame. To do that, we're going to call the entry function, and then in between the parentheses I'm going to pass in input underscore frame. So we are now creating an entry field inside our input frame, and input frame is being created inside our window. Then we're going to add a comma and pass in font equals to a tuple. Then we're going to give a font type of our choice. Let's say Arial. Then the font size of 18. We're going to say bold. Again, I'm going to add a comma and then give a width value of 45, comma, and then justify equals to right. Then we're going to store everything in a variable called input underscore field. Then finally, we're going to say input underscore field dot grid. Then in between the parentheses, I'm going to pass in the row equals to 0, and then a colon also equals to 0. So let's actually run the code. So as you can see, here is our input field for our calculator, and we can add some couple of text inside. So let's actually increase the height of the input field. But before that, we're going to create a comment. I'm going to call it increase the height of input field. Then I'm going to say input field dot pack. Then I'm going to pass in iPad y equals to the value 10. So the iPad here creates an internal padding to increase the height of our input field. So let's run the code and see that in action. As you can see, the height of our input field has been increased. So let's now start creating the buttons for our calculator. And the first thing we're going to do is to create a frame also for the buttons. So I'm going to add a comment and call it button frame. And let's actually add a comment for our input frame also. So I'm going to say input field frame. And back to our button frame section, let's now create a frame for our buttons. So I'm going to call the frame function, and then inside the parentheses, the first argument is going to be where we want to add our frame. Again, it's going to be the window object, which is win. Then a comma, and then I'm going to add a width to our frame and set it to the value 310, comma, and then a height value of 270. So I'm going to set our frame to a variable called buttons frame. And finally, we're going to say buttons frame dot pack. So now that we've created the frame for our calculator buttons, let's now start adding the individual buttons. the first couple of buttons will be for the first row of our calculator app. So I'm going to say button, and this button is going to be inside our buttons frame, then a comma, and then we're going to say text and set it to the string C, which is the value for our button. Then I'm going to give a width for our button, which we're going to say 38, and also height equals to the value 3. Finally, we're going to add .grid at the end of our button function. The first thing we're going to pass in is the row for our button, which is 0, comma, and then the column, which is also 0. So the row and the column is used to position our button inside the app. Then we're going to add a comma and then column span equals to 3, which is going to be the amount of columns that our button is going to occupy. Then a comma and then pad x equals to 1, and also pad y equals to 1. So the pad x and the pad y is going to give us a little spacing outside the borders of our button. So let's store all of this in a variable called clear. And when I actually run the code, then here is our button at the center of our app, which is pretty awesome, right? Now let's actually create our second button. So I'm gonna call the button function and then pass in the button's frame, comma, and text is gonna be the division symbol, comma, and then size of the width is gonna be 10. Also, the height is gonna be 3. Then we're gonna add the grid method, and then row equals to 0, comma, then column is gonna be 3, and comma, then we're just gonna pass in pad x equals to 1, and also pad y equals to 1. Finally, we're going to store everything in a variable called divide. And when I run the code, then here is our button created inside our app. Now, let's actually start creating the buttons on the second row of our app. So I'm going to add a comment. Let's say button second row. Then create our first button. We're going to say button and then pass in the button's frame, comma, then for the text, I'm going to set it to the value 7, then a comma, then for the width, I'm going to set it to the value 10, another comma, then height equals to 3. Finally, we're going to add .grid. Then our row value is going to be 1, and then column is going to be the value 0, comma, then for pad x, I'm going to set it to the value 1, comma, then pad y is also going to be 1. Then all you need to do now is to store all of these in a variable called 7. And let's run our code and have a look for our app. And here is our button of the value 7 inside our calculator. So let's now add other couple of buttons on the second row. To do that, I'm just going to copy our button and then paste it right below here. Then change the value of our text to 8. Again, the value of our column from 0 to 1. Finally, I'm also going to store everything in a variable. Let's say 8. Again, I'm going to paste our next button. This time, the value of text is 9. Then, the value of column is 2. Then also, store everything in a variable. Let's call it 9. Finally, I'm going to paste the last button for our second row. And the value of text is going to be the multiplication symbol. Then, the value of column is 3. Then finally, store everything in a variable called multiply. Now let's run the code and have a look for our app. So here we have our buttons 7, 8, 9 and then the multiplication button. Now let's start adding the buttons for our third row of the app. So I'm going to add a comment. Let's call it button third row. Then I'm going to paste the button that we copied earlier. So for the value of text, I'm going to say 4. Then this time around, the value of row is going to be 2. And for column, it's going to be the value 0. Then we're going to store all of these in a variable called 4. And when I run the code, then we have our button with the number 4 on the third row of our app. So let's actually add the rest of the buttons. I'm going to paste our button, then change the value of text to 5. And for the value of column, it's going to be 1. Then store everything in a variable. Let's call it 5. Then I'm going to paste another button. Again, change the value of text to 6. And also for column, it's going to be the value 2. Then store all of these in a variable called 6. Once again, I'm going to paste another button. Also, change the value of text to minus symbol. And then for the value of column, it's going to be 3. And then store everything in a variable. Let's call it minus. And when I run the code, then here we have our button 4, 5, 6 and minus inside our app. Now we're going to start adding the buttons for the 4th and 5th row of the app. So I'm going to create a comment. Let's say button 4th row. I'm going to paste my button. Then I'm going to paste another one. Again, add another button and another one once again. So our 4th row is going to have 4 buttons and the value of text is going to be 1. And for the second button here, it's going to be 2. Then the third button here is 3. And then for the 4th button, it's going to be the plus symbol. And we're going to change the value of row for the buttons. So all the values is going to be 3. And for the column, the first button is going to be 0. Then the second button 1. Then 2. And the last button is going to be 3. And finally, we're going to store all our buttons in a separate variable. So the first button is going to be 1. Then for the second button, it's going to be 2. And for the third button, it's going to be 3. And finally, the last button is going to be plus. So let's run the code and have a look for our app. As you can see, here we have our button of 1, 2, 3, and then the plus button. So for the final section on the interface, we're going to add the button for the last row of the app. So I'm going to create a comment which goes button 5th row and then paste our button. Again, I'm going to add another button and also the last one. So our last row for the calculator app is going to have 3 buttons. So for the text, the first button is going to have the value 0. Then the second button is going to have the decimal symbol. And finally, the last button is going to be the equal symbol. So for the value of row, all the values is going to be set to 4. Also for the second button and then the last button. And for the column, we're going to give the value 0 for the first button and then 2 and finally 3 for the third button. Again, for our first button, I'm going to say column span and set it equals to 2, which is going to take extra space than the second and the third button.
Then I'm going to increase the width value to 24. Finally, I'm going to store everything in a variable called 0. Then, for the second button, I'm going to name it point. And finally, the third button is going to be inside the variable equal.
So let's run our code and have a look. Alright, here is our calculator app interface completed. Now, if you are curious and want to learn more about building app interface with Python and tkinter, I'm actually planning a course dedicated to just doing that. So, make sure you hit the subscribe button to get notified for more of my courses in the future. And on that note, we've come to the end of this tutorial, and in the next lecture, we're going to be adding the functionalities for our calculator software by doing addition, subtraction, multiplication, and division of numbers. So, I'll see you in the next lecture. Take care.
In the previous lecture, we learned how to code and design a calculator GUI app using Python and tkinter. But as we all know, the calculator doesn't perform any tasks in calculation of numbers. So in this lecture, we're going to be looking at how we can add all the various functionalities of our calculator buttons and also have it to do all the various operations. So let's get started. The first thing we're going to do is to have our app display all of these numbers, meaning when we click on any of the button here, it's going to show the value inside this input field. So I'm going to create a variable called input underscore text and set it equals to the string var function. So the string var is used to hold string data in Python and then retrieve it later in our code. So when we click on any of the button here, the string var function is going to help us hold on to that value of the button. And on the section where we defined our input field, we're going to say text variable equals to input underscore text. Back to where I defined the string variable, I'm going to say expression equals to double quote. So in a few minutes, I'm going to tell you why we are defining the expression variable here. Again, I'm going to create a function. Let's call it button underscore click. And then in between the parentheses of our function, we're going to give our function a single parameter. Let's call it item, then a column. And then I'm going to call the global keyword. And then pass in our expression variable. So in Python, we use the global keyword to modify variables outside the scope of our function. In other words, we want to modify this expression variable here. So we use the global keyword to refer to and modify the variable. Then I'm going to say expression equals to expression plus str parentheses, then pass in item parameter from our function. And lastly, we're going to call our input underscore text, then dot set, and then pass in our expression variable. Then I'm going to scroll down to our button section. So here on the button 7, I'm now going to add the functionality of this button. In other words, when we click on the button 7, then it's going to display the value 7 inside our input field. So I'm going to add a comma, then say command equals to lambda, then a column, and then call our button underscore click function. And finally, in between the parentheses, I'm going to pass in the value 7. So we use this command here in tkinter to add the functionalities of buttons. And all the functionalities of that button is going to be inside a function which is created as button underscore click. And you might be wondering about this lambda here. And what this actually means is that the lambda is an anonymous function, meaning a function without a name. Also, this function can take any number of arguments, unlike the normal functions that evaluate and return only one expression. However, let's now review our button underscore click function. So, our function takes one parameter, which is item, and this parameter holds onto individual values of our buttons. Then, the global expression that we defined previously is then being concatenated with our item parameter. In other words, when we click on any of the button from our app, let's say the button 7, then our item parameter is going to be that value 7. And then we're going to assign our global expression to be the string of that value 7. Then finally, our function is going to set input underscore text to our expression. If you remember, the input underscore text is the string variable we defined previously, which is a function that holds onto data in Python, and then pass it as text variable to our input underscore field. So we say text variable equals to input underscore text. So let's now run the code and test our app. When we click on the button 7, we can see that the value 7 is being added inside our input field, which is pretty awesome, right? Again, when we press on this button, the button underscore click function continuously keeps updating our input field whenever we press this button. So now, let's start adding the functionalities of the rest of our buttons. So, after the button 7, we're going to add the function for the button 8. Then, I'm going to say command equals to the lambda function, then a colon, and then we're going to call our button underscore click function. In between the parentheses, we're going to pass in the value 8. So for the button 9, I'm going to copy this command statement, and then a comma, and then paste our command statement. Finally, I'm going to change the value inside the parentheses from 8 to 9. Again, for the multiplication button, I'm also going to add a comma and then paste our command statement. So instead of the value 8, I'm going to pass in a single quote and then the multiplication symbol. So to add the functionalities for button's third row, I'm going to use the multiple cursor. So hold the Alt key and then click on the button 5, 6, and then the minus symbol. Now we can add multiple code at the same time. So I'm going to add a comma and then paste in our command function. Then I'm also going to erase the values inside the parentheses. Now I'm going to pass in 4 for the first button and then 5 for the second button here. Then the value 6 for the third button. And finally, I'm going to pass in single quote, then the minus symbol. Again, for our button fourth row, I'm also going to add my multiple cursors, then a comma, and then paste the command statement. Then, in between the parentheses, for the first button, it's going to be the value 1. Then, for the second button, I'm going to pass in 2, and then the third button, which is 3. And finally, I'm going to pass in single quote and then the plus symbol. So finally, on the last row of our calculator app, I'm going to add the functionalities for only the 0 and the decimal button. I'm going to add 2 multiple cursors, then a comma, and then paste the command for the buttons. So in between the parentheses, I'm going to pass in 0, then a single quote, and then the decimal point. Now I'm going to head over to the first row. So on this row, I'm going to add the functionality for only the division symbol. So I'm going to add a comma and then paste our command statement. Then change the value of 8 to single quote, then the division symbol. However, now that we've added the functionalities for most of our buttons, let's now run the code and have a look. So as you can see, all our buttons are now passing its values to our input field here at the top. But one thing to note here is that we haven't added the functionalities for the clear button and also the equal button. So let's go ahead and do that. So for the clear button, we're going to create a separate function for that. But before doing that, I'm going to create a comment. Let's call it function to clear the input field. Then define a new function called button_clear, then parentheses. Our function is not going to take any parameter, then a column, and then we're going to refer our global expression. Then set the value of expression equals to an empty string. And finally, we're going to say input_text.set and then also pass in an empty string. So the button clear function we just created will clear our input field by setting the value of input_text to an empty string. So now that we've created our clear function, let's now pass it as a command to the clear button of our calculator app. So on the first row where we created our clear button, I'm going to add a comma and then pass in command equals to the lambda keyword and add a column. Then finally, I'm going to call our button_clear function. Let's now run the code and test our clear button. So as you can see, I'm actually adding values from our buttons to our input field. And when I click on the clear button, then everything disappears from our input field. So we're going to add an expression, let's say 3 times 5. Then we can see that we actually don't have the functionality for the equal button. So let's go ahead and add the functionality for the equal button. So I'm going to add a comment, let's call it function equal button. Then I'm also going to define a function called button_equal. And this function is not going to take any parameter, then a column, and then refer to our global expression. Then result equals to str, then parentheses, and then eval parentheses, then pass in our expression. Now I'm going to say input_text.set, then pass in the result of our expression. Finally, we're going to set expression equals to an empty string. So this function we just created calculates the expression inside our input field by using the eval function in Python. Then we set our input text to the result of our calculation. And finally, we set expression equals to an empty string after the calculation. Now, let's pass in our function as a command to our equal button. So, I'm going to scroll to the 5th row where we created our equal button and then say command equals to lambda, then a column, and then button_equal function. Now let's run the code and have a look for our app. So if we add an expression like 10 multiplied by 5, then press the equal button, which is equal to 50. And I can use the clear button. Again, 8 divided by 2 which is 4. Now our calculator app is completed. So congratulations for your hard work. We've